This is what a commercial firewood processor looks like, and the splitting wedge that makes the actual piece of firewood right there, that's what we're going to fix today in this video. So stay tuned and see how we do it. So this one here is a, I believe, 12-way wedge of a firewood processor, and this one here is an 8-way wedge. Well, something got wedged in here, and you see it just tore the whole piece apart. The weld didn't really break, the piece tore out. And then over here, this piece here bent real nice, tore out right there. Also, weld didn't break, piece tore out, and right there. So this is AR 400 or 500. I'm not 100% sure on this, but it's hard. It's hard as a rock. You're not bending it. You're not bending it back. It's not going to happen. Even in a press, you're not really bending it back. The cylinder that pushes this is like a 60 or 80 ton cylinder. So it just, a piece of wood gets in with a knot or it goes sideways and it just tears shit up, and you can't really fix it per se. So our plan is cut this here, straighten that part out, then there will be a little bit of a wave in it, but as long as the front is aligned correctly and everything is going to work again, that's probably going to be fine. Then resharpen all of this when this is off, weld it back in place, good to go. Here you can tell these here are a little bit longer. This one is already a little bit shorter. This one already came off once, just like that, got cut and welded back in place. Same here. The idea is get the excess weld and the old broken material out of there, because this is all brittle and work hardened. So I really don't want to weld to the old piece. Then cut this straight down. This is all going to be torch cut or plasma cut. You can't cut it with a saw. It's just way too hard. And you can torch cut the weld and the teeth as long as nobody used like a MG600 or some stainless based material on it. Once you use stainless material on it, you either need to carbon AR gouge, plasma cut. You can't torch cut anymore. It doesn't flow with the stainless. So there you go. That's the plan. We're going to try to do this with a torch. I don't think anybody welded stainless on it. And then we're going to weld this back in, and I'll fill you in what we do then when we get to it. Good enough, I think.
So, mode.
Yep. Make 2T, make 4T, stick. This one is
amps, probably. We're gonna start at 100 actually.
not 110, 115.
Yeah.
So what do you want for a hot start and arc force? Looks good.
Looks good.
No pulse, no nothing. There you go. Well, let's see how that works for you. Otherwise, you got to go a little bit up.
Okay.
So here, this is Rock Mount Polaris A. That'll be the right rod for that AR plate. Other way. Yep.
Look good.
Looks great.
Wait a minute. Got my Walmart helmet.
It could come in a little bit, but if you weld on the inside, it'll come by itself.
How's that?
Yep, they're right there.
Turn it up a little bit. the other one prep, tack it in.
All nice and symmetrical. I like it. A little bit tilted to the outside for some relief. So in real life, what you just saw in about 4 minutes was over 90 minutes of stick welding. Believe it or not, 90 minutes. But the results speak for themselves. I think it turned out really good. Customers running it already for 2 weeks now. Hasn't broken yet, so we're good to go. We'll see you on the next one. And if you think this is all shilling here, it could be further from the truth. I'm showing with you decades of real work in the industry and probably the best kept secrets in the industry, the rock mount welding rod and the HTP welding machines.